Hey, Algebra 2 Honor students. This is going to be Unit 14, Day 6, and today we are just doing some more sketching practice. So nothing new today, but Unit 14, Day 5 is pretty heavy. There was a lot of stuff thrown at you, so I think it would be good for us to just kind of have a practice day here. So I'm going to sketch two examples with you of one cycle to start a sine curve and then a cosine curve after that. Once we're done with those two examples, we'll find a way to get some more practice next time we are in class. So let's take a look at this example right here. The first thing that we're going to do is rearrange this such that we can clearly identify the amplitude, the frequency, the period, things like that. And then we're going to slide that 1 to the end because that 1's really the vertical shift. And I'm used to seeing the +1 at the very end. So first and foremost, let's write this as -3 sine of that frequency of 2 has to get factored out to leave you with x minus, now factoring out the 2 there is really like dividing this by 2 to get a pi/8 there. It's like multiplying this by a half if you want to think of it that way. And then +1 goes to the end. So that this is now the vertical shift. Make sure that -3 stays attached to the amplitude out front of sine. And because this is a negative out front, when I sketch what the parent graph looks like, the parent of an upside down sine graph looks something like this. So in the end, we're going to see a transformed version of this parent. And let's get right to it and start identifying some of the key information. So we have that this has an amplitude of 3, according to the vertical dilation out front. The frequency that I factored out is 2, which tells us that the period is 2 pi divided by that. 2 pi over 2 is pi. Okay, after we get the period, next thing I like you to identify is the phase shift and the vertical shift. The phase shift, now that we've factored out the frequency, is going to the right pi/8. And then finally, the vertical shift is that we're moving up 1. So we've really accounted for all the different transformations that are happening here. But now at this point, there's a couple other things I want to identify, including the range of the graph. And then we'll determine the start point, the end point, and the midpoint. So let's talk about the range first. Remember, for range, you're always going to start with -1 to 1. That's the range for the parent. And then there are two things that affect the range, one of them being the amplitude. So the amplitude is 3. We're going to multiply by that to now get -3 to 3. And then after multiplying by the amplitude, we're going to add on that vertical shift. These are all things that would affect the y values. So if I add on the vertical shift, which is a +1, -3 plus 1 brings you to a final range of -2 to 4. So when I go to make my sketch, I'm going to make sure that the y values span from -2 to 4. Let's talk about the starting location. Okay. So where does this graph start? Well, because of the phase shift and the fact that we're moving to the right pi/8, that's where we're going to start. Okay, now the y value for the starting location, the start, the middle, and the end that we determine, they're all in the middle of the range. Okay, and they're all on that thing that I call the wrap line. The middle of the range here is 1. That's what's midway in between -2 and 4. So that's what I want you to write down here. It is also exactly equal to where that vertical shift is. Let's remind ourselves, how do we get to the end point then? Well, the end point is from the starting location, add on the period. So we're going to take pi/8, and then we're going to add on pi to that. When I add on pi, we do need a common denominator, so this would be the same thing as 8 pi/8, which is now at 9 pi/8. Okay, so the end is also 9 pi/8, comma 1. The end y value is the same as the starting y value there. Last but not least, let's talk about the midpoint. Midpoint y value is still the same, but midway in between 1 and 9, it's going to be 5. So 5 pi/8 is going to be the midpoint, and now that we have all of our critical info, which is a lot, we can make a really accurate sketch for one cycle of this graph. So when I go to make my sketch, I'm going to set up my axes. I actually, since I'm shifting to the right, don't need any negative x values. So I'm going to put my y-axis pretty close to the left-hand side here. We do need a range from -2 to 4, so I'm going to go ahead and just make every space 1 unit on the y-axis. The line y = 1 is the wrap line, according to the vertical shift. That's where the start, end, and middle points are going to be. So it's kind of nice to include that as a dotted line, although I guess not completely necessary. And in terms of a scale on the x-axis, you can make every 1 space or every 2 spaces pi over 8. It depends how much room you gave yourself here. I'm going to make every 1 space pi over 8 just to make sure that this all fits nicely. So if that's 1 pi over 8, 2, 3, 4, this would be 5 pi over 8, 6, 7, 8, 9 pi over 8. Okay, we're now up to the point where we can make our sketch. So the start, pi over 8, 1. The middle, at 5 pi over 8. And the end at 9. In between the start and the middle, if it's upside down sign, here's where we have to go back to that parent. Don't forget that this is the parent function, because it's really easy to forget that we're reflecting this over the x-axis because of the negative. But the first thing you're going to do is go down to the lowest point of the range. So in between the start and the middle, you have to be down at -2. In between the middle and the end, you have to be up here at +4. And those are the 5 key points that I would expect to see plotted. And man, that is a nice sine curve, guys. We did a nice job with that one. So hopefully putting all those pieces together makes sense after seeing some of the examples in yesterday's notes. I'm going to do just one more with you. Like I said, here was a sine example. Let's do a cos one. And the cos one that I'm going to do is on page 30 of your packet. So there's some good practice here that I'll just do one of them, and I'll give you some time in class to do the other 2 next time we're together. So the nice thing about page 30 is it's already nicely set up. We have a grid, we have all the questions we have to answer, start point, end point, midpoint across the top. We're ready to go here. Well, I said we're ready to go, but we do want to make sure that when I get started here, you do factor out that frequency. So when I take out the 2, it leaves me with x plus, okay, taking this and dividing it by 2 is now pi over 12 with a +1 on the outside. Instead of dividing by 2, if multiplying by 1/2 makes more sense to you as to why this becomes pi over 12, that's the same thing. All right, let's see if we can quickly develop this list here. Amplitude is 2. Frequency is 2. Period is pi then. Same period as before. Phase shift, we're going to the left, pi over 12. So sometimes I'll just write that as negative pi over 12. If you want to draw an arrow to the left, that's fine too. We are going up 1 due to the vertical shift. And let's see what the range is going to be here. So the range starts off -1 to 1. Then because of the amplitude of 2, we're going to double it. So now we're at -2 to 2. And then the vertical shift of +1's the last step. So now we're at -1 to 3. So here is the range of y values. Okay. So before we go and make our sketch, let's go ahead and talk about start point, end point, midpoint. The start is going to be to the left pi over 12. So negative pi over 12, comma. I didn't draw the parent function yet. I probably should do that, right? Normal looking cos looks like this. And I say normal looking cos because there's no negative out front, so it's not the reflected form of cos. Well, where does cosine start? It starts at the highest point in the range. The highest point in our range is 3. So negative pi over 12, 3 is going to be the starting point. Let's talk about the end point. To get to the end, you're going to add on the period here. So let's see, negative pi over 12 plus pi, which is really 12 pi over 12, is now at 11 pi over 12. And notice how it's also at the highest point in the range, 3. All right, last thing we have to ask ourselves is what's midway in between -1 and 11? You average those numbers, you're going to get 5. Okay. And then last but not least, what's the y value of the midpoint? This we have to be a little bit careful about. For sine, if you look back at the last example, all the y values were the same, but look at the y value for this midpoint. It should be the lowest point in the range, which is -1. So we do want to be careful that we identify this correctly. They're not all the same across for the y values, especially in the case of cosine. We are going to the left a little bit. I am probably going to make my scale still just 1 space represents pi over 12 on the x-axis. All right, so let's see. So if I do every 1 space even for the y values, here's -1, 1, 2, 3. And we have the wrap line at y equals 1 again, so I like to include that. Okay, this space right here, I'm going to call that negative pi over 12. So if I go 1 space to the left, so this is positive 1 pi over 12, 2, 3, 4, here's 5 pi over 12, 6, 7, 8, 9, 10. I have to end at 11 pi over 12. So when you're making your scale, if you had gone up by 2s, you might have gotten, yeah, I think we're probably going to go off the page a little bit here. Not a big deal, but in general, when you're deciding a scale, if you have a larger grid form to choose from, we should be good to space it out even more if needed. All right, first point, negative pi over 12 comma 3. So that's right there. The midpoint 5 pi over 12 is down at negative 1. So that's right there. And then 11 pi over 12 is up at 3. Okay. So in between the start and the middle, so in between negative 1 and 5 is going to be 2 pi over 12. That's when we hit the wrap line. And in between 5 and 11, that's going to be at 8 pi over 12, so 6, 7, 8. That's when we hit the wrap line again. So here is what one cycle of that cosine graph looks like. Okay. So that's the process. Hopefully seeing 2 more examples really gets you to a place where you're feeling more confident about the process. But if you need a little bit more assistance from me, like I said, we have 2 more examples that we'll do in class next time. So if you want to get started on these, you're more than welcome to, but I'll give you some time in class to work through these. We'll go over them and then get to some additional practice for homework. So that is it for Unit 14, Day 6. Have a great rest of your day.